So here's our circuit drawn out on paper. The same circuit that we put into our LT-SPICE simulation to see if we would get the right voltages going into our laser and coming out of our solar cell and going into our speaker, just so we could get an audible noise. So I'll explain the channels more on the actual circuit board itself, but essentially we have both of our channels coming in to a mixing node, which is summed over our op amp, and the gains are from the aux is 10 to 51 kilo ohms, so that's a gain of 5, and from the mic channel it's 1 kilo ohm to 51 kilo ohms, which is a gain of 50, and that gets us from about it gets the input of about 10 millivolts from the mic and about 0.2 to 0.5 volts up to 0.5 volts for both coming into the bias T, and that is our high passing frequency that comes from our audio signal and allows it to pass once it's biased with the DC voltage from the bias T, which is 9 volts, which generates the power for our laser, and that is the transmitting side of our circuit. On the receiving end of our circuit, we have our solar cell, which picks up the laser and generates a voltage based on it, and it also takes in the frequency from the laser. Then we have a capacitor right after that to filter out any DC voltage that would create static in our noise. And we have, this is actually a different resistance than we ran in our LT-SPICE. We ran 10 kilo ohms in our LT-SPICE, which gave us the proper voltage for this speaker, the 8 ohm speaker, to have enough current for a decent sound. But when we actually use our circuit, as you'll see, it didn't work this way, so we had to kind of skip all this action here and just hook up the solar cell to the capacitor and then the speaker directly to this node right here and then to ground. So here's our actual circuit board. This is the transmission side of things. Right now I have my laptop hooked up through the aux cord, and we have a 9-volt battery supplying power to our board. So we have two channels coming in here. We start off with the mic channel and the aux channel. First I'll explain the mic channel. So we power our mic with 9 volts going through 2 kilo ohms of resistance, and then on the other end of the mic is a 0.47 microfarad capacitor, which leads into a 1 kilo ohm resistor, and then that goes to our mixing node. And then on the other end of our mixing node, from our aux input, we have the aux going to ground, and then the other end comes into another 0.47 microfarad capacitor, which is in series with our 10 kilo ohm resistor. And that means pretty much that the gain for our mic input is going to be 10 times greater than the gain for our aux input. So next, going into our op amp, we have our positive and negative supplies, which are just 9 volts and ground. We're using a quad op amp also because it gives us a better frequency read. And so over the negative input, the inverting input of the op amp, we have a 51 kilo ohm resistor. So our gain is about 50 times for our mic input, which is what we want to get the 10 millivolts up to about 0.5 volts. And then it's around 5 times from the aux input. So that meets with our bias T over a capacitor, a 10 microfarad capacitor. And the bias T, essentially, we're running from ground, our 9-volt power supply into a resistor, which is in series with our 2 millihenry inductor. And that inductor, that part of the bias T provides a low pass frequency DC bias, and it's providing 9 volts that allows us to power our laser essentially, and allow the high pass frequency from the signal that we're getting after our op amp to come in and be part of the mixed signal that's now going through our laser over to our receiving board. Our receiving board we tried to have all this stuff here, but we couldn't get it to work. Originally, we're not sure if it's the busted op amp or something along those lines, other broken circuit elements, but our gain, originally we had a very large gain because we had an extremely large resistor over our inverted input of our op amp. So we thought that might saturate it too much, so we brought it down, and we brought it down to a gain of about 50 because we were getting a reading of around 80 millivolts from our solar cell picking up the laser signal. So that still wouldn't work, so we just thought it might be the circuit elements that were broken. So instead, we opted to just take our speaker and plug it, the positive end just right into a capacitor that was in series with the positive end of our solar cell, and then the other end to ground, and the same for the solar cell. And that's basically our receiving board at this point. The sound quality isn't good, but you can hear it. I'll show you right now. So here I'm playing a song, as you can see. It's moving, time is going on, and now I'm going to aim my laser at our receiver, and you can hear the music begins to play. It's quiet, but the camera should pick it up. And now if I just try to use the mic, if I just tap the mic, you can sort of hear the static from it. And that is our circuit.